Good afternoon, students. Welcome back once again to the mathematics class. In the last class, we have seen the examples based on some standard derivatives of standard functions. So let's see next rules of differentiation. Next heading is rules of differentiation. So first, if k is constant, then d by dx of k, which is equals to 0. So let take y equals to k as x changes to x plus delta x. Suppose y changes to y plus delta y. Since y is constant function, we have y is constant function, we have y plus delta y, which is equals to k, so that delta y is what? Is equals to 0. Y equals to k means what we get? Delta y. K minus y equals to k means it is k minus k. So delta y, which is equals to 0. So hence what we can write here, delta y upon delta x equals to 0. Therefore limit delta x tends to 0, delta y by delta x, which is equals to 0. So therefore dy by dx, which is equals to 0, or d by dx of k, which is equals to 0. Thus the derivative of a constant is 0. Constant function is 0. So already you know the differentiation of constant is 0. So we have proved this one also. So next, for example, let's see next second one. If u is function of x and k is constant, then d by dx of ku, which is equals to k into du by dx, right? So let y equals to ku, take it as equation 1, as x changes to x plus delta x, that is small increment or a small change we can say. Suppose u and y changes to u plus delta u and y plus delta y respectively, right? So hence y plus delta y, which is equals to k, u plus delta u. Take it as equation 2. So subtracting 1 from 2. 1 from 2, we get delta y, which is equals to k u plus delta u minus of ku. So here delta y, which is equals to plus ku minus ku get cancelled. Only k delta u remains. So now limit delta x tends to 0, delta y by delta x, which is equals to limit delta x tends to 0, k delta u by delta x. So after applying limit, what we get? Dy by dx, which is equals to k outside the limit delta x tends to 0, delta u by delta x, which is equals to k times of du by dx. So which is nothing but thus the derivative of function, what we can get the conclusion, thus derivative of function multiplied by a constant is constant times the derivative of a function. Derivative of a function, right? So thus the derivative of function multiplied by a constant is a constant times the derivative of function. So let's see, for example, for example, d by dx of 4x cube, which is equals to 4 keep outside d by dx of x cube. So which is equals to 4 into 3x square, that is 4 to the 12x square. So it is x to the power of n into x to the power of n minus. So similarly, second one, 2 sin x is 2 d by dx of sin x, which is equals to 2 cos x. Next third one, d by dx of 5 log x, that is 5 d by dx of log x. So that is nothing but 5 into 1 by x, which is nothing but 5 by x. So next we will see derivative of sum. Derivative of a sum, right? So let's see, if u and v are functions of x, then what we have, d by dx of u plus v, it is du by dx plus dv by dx. So let's see, let y equals to u plus of v, take it as equation 1. So as x changes to x plus delta x, suppose u, v and y changes to u plus delta u, v plus delta v and y plus delta y respectively. So therefore just substitute here, y plus delta y equals to u plus delta u, v plus delta v, take it as equation 2. So subtracting 1 from 2, subtracting 1 from 2, we get delta y, which is equals to delta u plus delta v, dividing throughout by delta x and taking the limit as delta x tends to 0, we get limit delta x tends to 0, delta y by delta x, which is equals to limit delta x tends to 0, delta u by delta x plus delta v by delta x, so which is equals to limit delta x tends to 0, delta u by delta x plus limit delta x tends to 0, delta v by delta x. So replacing v by minus v, we get it is d by dx of u minus v is nothing but, so finally what we can write here, dy by dx, which is equals to du by dx plus dv by dx. So the next, replacing v by minus v, we get d by dx of u minus v du by dx minus dv by dx. So this can be, so this rule can be extended to a finite number of function of x if u, v, w are functions of x, then d by dx of u plus v plus w dash dash dash, which is equals to du by dx dv by dx plus dw by dx plus so on, right? For example, first one, d by dx of a cos x plus b sin x. So here d by dx of a cos x plus d by dx of b sin x, so which is equals to a outside cos x is differentiation is minus sin x plus b cos x. So here minus a sin x plus b cos x is the required solution. So next, one more example, d by dx of 2 root x 3 to the power of x 4 log x, which can be written as d by dx of 2 root x minus d by dx of 3 to the power of x plus d by dx of 4 log x. So 2 into 1 upon 2 root x minus 3 root x plus 4 into 1 by x, which is equals to 2 to get cancelled. 1 by root x minus 3 to the power of x plus 4 by x is the required solution. So with this we will conclude our today's lecture. In the next lecture we will see derivative of a product and their example, derivative of quotients and their examples, and finally we will see some examples based on all these standard forms. So till that